Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily lead code problem, and the problem's name is count sub islands. So the problem statement goes like this. You are given two m cross n binary matrices, grid 1 and grid 2, containing only zeros representing water and ones representing land. Okay, an island is a group of ones connected four directionally, horizontal and vertical. Okay, so basically the four directions are these. Okay, so these are the four directions. Then it's mentioned that any cell outside the grid are considered as water cells. Okay, so if these are the grid given to, let's say this is the grid given to you. Okay, anything outside its boundaries, here it's all water. Okay, so I hope till now it's clear. And an island in grid 2 is considered a sub island if there is an island in grid 1 that contains all the cells that make up this particular island in grid 2. So what the problem statement is saying is, let's take this example. And let's zoom in a little bit. So this is your grid 1. Okay, and this is your grid 2. So if there is a portion, for example this particular one, these red ones, okay, these are the cells which are also a part of an island in grid 1. Okay, so you have to return such cells, okay, or such islands whose all the cells uh, are part of a island in grid 1. Okay, an island in grid 2 is considered a sub island if there is an island in grid 1 which contain all the cells of the island in grid 2. Okay, so since four directionally we were to take the cells, so this was a island in itself, and it was part of some other island. All the cells of this particular island were part of some other island in grid 1, so that's why it's a valid sub island. Okay, so valid sub island. And you can see that these are not valid sub islands. Why these are not valid sub islands? See, this particular uh, island is having two cells. Okay, these two cells, and this particular island, okay, this entire one is not having all the cells covered in some island in grid 1, so that's why it is not a valid sub island. Okay, because only this much cell is covered in some island in grid 1. Okay, so you can see that this cell is covered, but rest of these two cells in the current island are not covered, so that is why it is not a valid sub island. Okay, so similar was the reason for the upper red box. So here you can see that all the cells in this particular island were part of some island in this particular grid 1. Okay, you can see all the cells are part of some other island. Okay, So as you can see, that's why it is the reason that it will be a valid sub island. Okay, so you have to return the number of such islands in grid 2 that are considered as valid valid sub islands. Okay, and before thinking of an approach, let's have a quick look at the constraints also. So according to the constraints, the length of the grid or the number of rows in the grid 1 and grid 2 will be equal, and same will be the case for the number of columns. Okay, and the number of rows and columns will be ranging from 1 to 500. Okay, and each entry in both of these grids will either be a 0 or a 1, 0 representing water and 1 representing land. Okay, so you have to basically return the number of islands that can be considered as sub islands in grid 2. Okay, so a very straightforward logic that is coming to my mind is, why not eliminate all the islands that are not valid sub islands? Okay, and how we will be doing so? In order to do so, what we will be doing is, we will be searching for such cells where grid 2 is having 1 and grid 1 is having 0. Okay, so for example, this was one example where grid 2 was having 1, and here in this particular area, as you can see, grid 2 was having a 0. Okay, so here you can see. Okay, so if you start from here, basically this point, and traverse 4 directionally to the all the neighboring ones, then you will cover one island. Okay, okay, and while doing so, each time you are visiting a cell, you will mark it as a 0. Okay, so things will happen like this. You started from this one, okay, this particular one, and you marked it as 0. Okay, then you went 4 directionally. Okay, these three sides were covering water, and this was the only land containing cell. So you reached here, you marked it 0, and then you again went 4 directionally. You have already marked it as 0, so you cannot go here, and the only possible way to go is here. Okay, then you again reached this, you marked it at 0 as 0. Okay, then you eliminated this entire island in a way. Okay, there is no longer any land here. These are all zeros representing water. Okay, and you can see that this particular cell is having 0, while in grid 2 this particular cell is having 1. So you can start eliminating from here also. Okay, from here you cannot go anywhere else for directionally, so this is the only cell and you will eliminate it. Okay, once you are done with it, the only job is remaining is to count the number of islands. Okay, we do not have to worry about any sub islands or anything. All the islands that you will be forming right now after elimination of non sub islands will be sub islands. Okay, so let's say I started from here, I went 4 directionally and I covered all these. Okay, so this was one sub island. Then I went again 4 directionally from this one. This was again one sub island. Then it was again one sub island. So in total 3 sub islands will be there. So the first step was to eliminate non sub islands. Okay, and the second step was to count the number of islands in grid 2. Okay, these all things will be done in grid 2. Okay, the whole procedure or these two steps will be done in grid 2. And once you are done with it, you will be having your answer, which will be this count of islands. Okay, this will be your answer. So let's see how we can do this programmatically. Okay, so for that, let me bring the code to the board. It's a two-step process. I will again repeat. The first step is to eliminate all the known sub-islands, and in order to do so, you will be finding the cells at which the current value is 1 in grid 2, but the corresponding value in grid 1 is 0. Okay, and starting from there, you will start eliminating the island. Okay, going four directionally from that cell. So let's take a fresh slide to see how we have implemented this approach. And let's remove this toolbar also. So now it's gone and we can start discussing the logic. So first of all, these will be the two grids that will be given as input to you, and this is the function that you have to complete, count sub islands. Okay, so you have to return the number of sub islands in grid 2. So these are just couple of variables that we are using, number of rows and number of grids. Since the uh, number of rows and number of columns, sorry. So number of rows and number of columns in both of the grids will be equal. So but for first part we will be eliminating the non sub islands. Okay. Okay. So for that, what we are doing here is, as we talked about, we need to search for the cells which are 0 in grid 1 but 1 in grid 2. Okay, and starting from those cells, we will be eliminate the whole island that is containing those cells. Okay, so let's see how we have implemented this eliminate island function. Basically, this particular function is just a depth first search. Okay, DFS. And if you are hearing this name for the very first time and you are not familiar with it, then what I will do is I will provide link of an article describing what depth first search is and when and how to apply it and a basic implementation of it. Okay, so you should definitely head over to the link and explore that article. And assuming that you have familiarized yourself with this particular approach, basically it's nothing fancy here. We just start, it's just a recursion. So we start from a point and we go step by step to a point where we cannot proceed any further. Okay, then you return from this particular point, and once you back trace your one step back, and then you see whatever the other possibilities that you could have explored. Okay, so this is just depth first search. Why depth first search? Why the name? Because you are trying to go to the maximum depth of our decision making chain uh, till you are able to do so. Once you are not able to go any further, then you try to take one step back and explore other options, take one step back and explore other options. So like this. So this is what is DFS is in nutshell. Otherwise it's the standard recursion. So what you will be doing is, in this particular function that is just a DFS call, uh, you were allowed to go in four directions. Okay, so consider yourself standing at the origin. So what will be the four directions that you will be able to go? So these will be this 1 and 1 0, minus 1 0. Okay, and 0 1 and 0 minus 1. Okay, I hope you are able to understand what I mean to say here. So these are the coordinates, you can say, in a way that is describing those four directions. Okay. And yeah, that's pretty much it. And then once you have made a directions array starting from the cell that you found, you know, uh, this 0 at grid 1 and 1 at grid 2, starting from that particular cell's coordinate r and c, you will be passing these coordinates to the eliminate island function and the grid, obviously, which will be the grid 2. Okay, so you need not to confuse yourself with what this grid value is. It is actually grid 2. Okay, so as I talked about that, we need to mark the current cell as water. Okay, marked as water. Then you will visit its neighboring cells in four directions. Okay, so these are the four directions. So the neighboring cells will be having some coordinates which can be easily derived from this directions array. The new row value or the row coordinate will be r plus the first entry, the first entry representing the row and the second one representing the column. Okay, and similarly new column can be derived. Okay, so once you are having the new coordinates, then you will see is it safe to go there. Okay, and what does it mean to be safe to go in the particular cell? So first of all, the first condition is being that this cell should be well within the boundaries of the grid. Okay, so within boundaries of grid. Okay, this is the first condition. The next condition is that there should not be water. Okay, in that particular cell, otherwise it's pointless to go there. Okay, because there not be it will not be the part of the island that we are trying to eliminate. Okay, so no water. Okay, and these conditions are there, then you will be returning false any of these conditions. Otherwise you will say okay, it's safe to go there, it is the part of the island that we are trying to eliminate. Okay, so in that case you will be making a recursive call to this function with the new coordinates. Okay, and the entire thing will be repeated, and once you exit from this particular function call, then the entire island that is not a valid sub island will be gone. Okay, so thing like this will happen uh, as we are able to see that this entire island is no longer an island. We have just made it part of water. Okay, because it was not a valid sub island. So then the next part comes in which you will just find the number of valid sub islands. Okay, count number of islands, and these will be the valid sub islands because you have already eliminated the uh, non valid sub islands. Okay, and for now you will be starting from a cell which is having both one entries in grid 1 and grid 2, and you will simply, you know, count the number of islands, such islands, and you will return that count. Okay, and this will be the whole approach and the logic. And for the cover island function, it's just may I have just provided another name to this eliminate island function. It's just making the call to eliminate island function, as you can see here, and in a way it's eliminate island function logic only. Okay, so and if we talk about the complexities here, time complexity wise, it will be order of number of rows into columns. Okay, and space complexity wise, since other than the recursion stack space, this recursion that we are using, other than this stack space, we will not be using any extra space, and in worst case it can be, or a loose upper bound can be considered to be as rows into columns here also. So these will be the complexities, and this is the approach. Okay, the whole approach. This is safe was to check whether we are able to go into the adjacent cell or not. And the whole logic was this, that first you have to eliminate the known sub islands and then count the number of islands remaining in grid 2. Okay, all things are needed to be done in grid 2 only. So I really hope you are able to understand the logic and the approach. If you are still having any kind of doubts or any queries in general, then you may ask them in the comment section. And I hope that this solution walkthrough added some value to your journey of honing your DSA skills. And keep solving more and more problems. And I will be seeing you in the next video. Thank you for watching.